I'm pleased to be up and to be able to give a talk. I'm not giving a Minnesota review. I'm going to be giving a brief talk and introduction that really kind of pulls together some pieces of work that when I came to the university in 1999, we started developing infrastructure, and it's kind of bearing some fruit right now. I owe a lot of credit to the list of people up on the screen and a number of others who are not listed on the screen who do all the heavy lifting and help get the work done, and so my appreciation to them. So I come from, like Yaba and Gary, the land of the north, part of the tundra that will not stop snowing, the never-ending winter in Minnesota this year. We've had 3 weekends in a row where we've had 8+ inches of snow, and I heard that this coming weekend we're supposed to get more. So eventually it'll stop. But we're in the facility where I'm at is in the Cottonwood watershed in southwest Minnesota. The Twin Cities is up there, so we're about 2.5 hours from the Twin Cities, kind of in the heart of corn and soybean production land. This may be a little bit hard to see, but at our research facility, again, kind of starting back in 2002, we started developing quite a bit of infrastructure. And when we start thinking about the individual practices, some of which we've been talking about over the course of the last few days, we've got some up here that that haven't been talked about, and some that are being talked about. But I'm going to kind of give you a little bit of run through and then a little quick snapshot of some of the things that we're doing right now. So we actually have a drainage ditch system that we built back in 2002. It consists of 4 channels. There's a research pair of channels in the middle, so we use a paired analysis design for this particular research. We've also got a side channel here that we've used we've conducted some side inlet control research that was of interest in Minnesota before our buffer law went into place. And on this side, well, this is an expansion channel, and if we get funding for a project that we've put in, we're going to develop that into another research channel. Here we've got, this area here, this was developed in 2008, 2009. It's a set of 6 constructed wetlands, and I'll go into a little bit more detail about that, but we've basically got 3 different types of pairs of constructed wetlands out there. We've got, from a project that Gary and Andre and I worked on a number of years ago, some bioreactors. We've got pairs of bioreactors here, or triplicates of bioreactors at the site. One of the new sites that we've just developed in this area, so when you start looking at this, we've got an in-stream, an edge of field, and now we've got an in-field, larger scale component for drainage work at the site. Of course, we've got other small plot drainage research and some of our field scale drainage research that we do, but this is actually going to be complementary to what we've got in our drainage area. So the goal of this work, and I should step back a half a step here. This work here is part of funding that's coming from our Minnesota Department of Ag Clean Water Fund, as well as some money that's coming through an NSF grant. And some of the work that we're doing in this field is looking at cover cropping, and we're looking at winter camelina as one of our cover crops. Now, the impetus and sort of one of our objectives was twofold. One was to try to look at these individual practices in a small watershed and look at the water quality, water quantity differences with these practices in and of themselves, and then sort of as that part of that treatment train. So we can look at the inflow and the outflow of all of these practices, and then at the end of the day, try to look at what was the benefit to the water quality when it finally left the farm through the drainage ditch system. The other component is a water quality modeling component, and I'll touch on that really briefly at the end, but we've got one of our collaborators, Brent Dazell, who's working with us, is using the SWOT model. And actually in our watershed, the Minnesota Department of Ag, since Yaba's kind of undercover, I'm not going to put him on the spot here. We have a certified farming program that farmers can enroll in, and so we're working not only with our own watershed, but also looking at working with farmers in the Cottonwood watershed who are enrolled in our Minnesota Department of Ag Certified Farming Program in terms of water quality practices, the use of their data that they've got to input into the model to make sure that our model is really kind of putting out these multiple practices on the landscape. So I'll just go into some details. This is a little bit more of a close-up zoom in of the site. Again, we've got a treatment and a control channel out there, and I'll show you kind of what we've got. We've got a low-grade weir in our treatment channel. So there's an elevation change of about a foot, so we're trying to hold water back. We slowly drain out water in between events and then use that as temporary storage. So we're hoping to facilitate either nitrogen uptake or denitrification from the nitrogen standpoint, as well as for phosphorus. So for our paired comparison, this was some of the early data that we looked at. For the first few years, we weren't getting any differences in nitrogen treatments. That has changed, and we were doing actually a fairly decent job in looking at the regression lines, the slopes and the intercepts for phosphorus. When we started looking at some of the more recent data, and I'm just showing some of the nitrogen data here, again, with 15 minutes, I can't go into gory details of everything, but we've got the solid yellow lines here at the bottom are the drain outflows from our ditches. So the black one is our control, the yellow one is our treatment, and we start looking at the nitrate flow or the nitrate loads that are coming out, or I guess Andre has concentration here. So we're looking at concentrations here. So one of the things that you see right away is that for the treatment area, the peak nitrogen concentration and the timing of how long that lasts is quite a bit lower from our treatment side, where we've got this low-grade weir put in place, compared to the control, which essentially is metering it out over a lot longer period of time. We're getting a lot less treatment of that nitrogen. And then you see a bit of a similar artifact here in the fall of 2017. So again, jumping to the next treatment part that we have here, this is our bioreactors. We went through a lot of gymnastics over one of our projects trying to look at different ways to implement sort of what we're calling phase 2 of our bioreactor research. We ended up looking at a modular bioreactor that can be put in place maybe at the end of a tile, for example, and then removed from that site and then recharged. The bioreactor material, whether it's corn cobs, wood chips, can actually be removed, reinstalled, and then put back in place. And so we developed this as a set of systems. We also had, in our first go-around with this, we were also looking at phosphorus reduction materials in them. So we've kind of broken that down. So our system, we're using a controlled drainage structure to meter water out into our bioreactors. We actually add some acetate, so we're supplementing carbon to the site. So we have our flow control, we have an acetate area, and then we've got our 9 bioreactors. The bioreactors are here where we have some coarse rock material at the bottom, followed by different layers of carbon material, which is wood chips and corn cobs. And then in the case of the phosphorus-sorbing material, we had crushed concrete, limestone, or steel slag on top. The nitrogen reductions, when we look at 2016, we were getting about in that low to mid 40% reductions for nitrogen, similar for phosphorus reductions. 2017, we had a couple of things going on. We had reduced our acetate addition for one thing, and we also had some redox temperature issues that I'll show in a second. And our nitrogen reductions were quite a bit lower in 2017, and we had reduced our phosphorus reductions. We've decided as a group to kind of abandon the idea of looking at phosphorus-sorbing materials because what we ended up seeing was that at the early part of the year, when we had low P concentrations in our water, pea-sorbing material acted as a source of pee in the system, and then later on acted to sorb it. So we were actually adding to the problem, and we don't want to do that. So we've decided that's probably not a good approach. So eventually when we publish that, we will be expressing that to tell people. Now, when we started looking at the nitrogen piece, and part of the reason why we saw this big reduction in loads was that we start looking at redox, and that's the red, the black, and the yellow lines here for our different bioreactor systems. And then we're plotting the water temperature here, and we see this very drastic difference in nitrate reduction related to redox as we went through the season. And so in our part of the world, again, kind of the frozen tundra, when we're trying to deal with nitrogen issues, especially early in the spring, April, May, when flows are high, we're losing a lot of nutrient. We need to not only deal with supplementing carbon that we have been, but we also need to start thinking about how are we going to warm this system up a little bit. And we've actually got some things in place that in 2018 we're implementing to actually heat some of that up and try to take care of some of that issue. When we look at our wetland sites, this is just some of the sites as you saw. We had some wet periods of time in 2017. This is a slightly different aerial view that I'll kind of talk a little bit about the design. So these three wetlands are surface flow style wetlands. There's three different levels of pools in here. There's a permanent pool and then two other levels that we will allow the areas to fill up to have some storage for us to reduce some of the loss of water. And then we have sheet flow that comes basically out through our control structures. We have another pair here. These are our vertical flow systems. So in Minnesota, one of the things that we have surface intakes, which are areas that are in potholes or depressions that tend to drain quickly when we get ponding, but they can also be a source of sediment. So in some of the cases of conversations we had over the years, we thought about putting in shallow, narrow-spaced tile. And so the idea in this is mimicking kind of a pothole in our constructed wetlands. So we've got tile that are about 15 to 18 inches deep, so we're talking maybe 40 centimeters deep, and about 15 feet apart, so roughly 5 meters. So they're narrow. And in this area, this is our pair of wetlands that probably no one would ever build, but it's a horizontal flow system. You wouldn't use it for ag drainage water because it's expensive, but there's about 18 inches of rock underneath that system. When we started looking at the actual discharge from the systems, we were seeing that there was differences in terms of how we were holding water back, which was one of our goals. And we started looking at there are some small differences, at least in the early on, the 29 through 2011 data, in the nutrient reductions. Now, one of the things, I'm going to jump back to this slide, one of the opportunities that we have is, thanks Gary, is that we can look at each one of these systems in terms of monitoring and managing the water levels. So right now we're actually holding more water back in one side than another side and trying to look at the nutrient reductions that way. And then finally, our field site, we don't really have any data from this site because it was just installed about a year ago. And so stay tuned for that. Again, I kind of mentioned the modeling. I just throw this slide up there that the majority of this watershed is ag production. And as I said earlier, we're working with a bunch of the farmers that are in the farmer working group from the Department of Ag, and we will use that as one of our outcomes. And a selfless plug, you're all invited personally by me to our August 16th, 2018 field day, and that's all I have to say here. Did I make it? Oh.